Good afternoon, students. Today we will learn the standard MM4A file, and our essential question is how to use the trig identities in simplifying trig expressions, and also how to prove our trig equations. How to simplify trig expressions and how to prove the trig equations. That's what we are going to use today, the trig identities. Now let us review what we have learned yesterday in the last two classes. So we have learned about the quotient identities, and we have learned about reciprocal identities, and we talked about Pythagorean identities. Today first we will prove the Pythagorean identities, and then we'll talk about the unit circle, and then go for simplifying the trig expressions. Okay? Now, as we know, in the quotient identities, tan theta is nothing but sin theta over cos theta. And we also know that cot theta is cosecant theta over cos theta. And in reciprocal identities, we have seen that sin theta is 1 over cos theta, and cos theta is 1 over secant theta, and then tan theta is 1 over cot theta. And the Pythagorean identities, the three Pythagorean identities that we have are sin square theta plus cos square theta is equal to 1, and tan square theta plus 1 is secant square theta. And then we have cot square theta plus 1 is cosecant square theta. We can write each identities in different forms also. The first Pythagorean identity we can write in two different forms. That is, we can write sin square theta is nothing but 1 minus cos square theta, and cos square theta is 1 minus sin square theta. Now, tan square theta plus 1 is equal to secant square theta. This we can write as tan square theta is equal to secant square theta minus 1, and cot square theta is equal to cosecant square theta minus 1. Okay? Now, let's see this one. Okay? Now, let's review a little bit our unit circle. In the unit circle, we have assumed that the radius of the circle we consider as 1. It's as 1 unit. Okay? And then we have seen the x and y axis. The x axis, the equation of the unit circle is x square plus y square is equal to 1. What is our x? Cos theta. What is our y? Sin theta. So now sin square theta plus cos square theta is nothing but 1. As we have already seen that in a right triangle. You see here, in a right triangle. Okay? In a right triangle. We know that if this is theta, this is opposite side and this is adjacent side. And this is hypotenuse. And we also know that a square plus b square is c square, our famous Pythagorean identity. So we will use opposite square here plus adjacent square is nothing but hypotenuse square. So now this opposite square for in the unit circle what we have is sin square theta, okay, plus cos square theta is nothing but 1. That's we have. That's our Pythagorean identity. This particular Pythagorean identity, and then we also take use of quotient and reciprocal in proving the other two Pythagorean identities. Let's see that one now. Okay? Now, divide entire sin square theta plus cos square theta is equal to 1 by cos square theta. See here? Divide entire thing by cos square theta, cos square theta, cos square theta. What do we get? We get, this is our quotient. Sin square over cos square. Quotient, tan square. 1 over cos square, reciprocal. Quotient, reciprocal. Pythagorean identity. This is our second Pythagorean identity. You got that? Isn't it so interesting? Let's go for the third Pythagorean identity. How do we do that? Now, let's divide everything by sin square theta. Sin square theta over sin square theta plus cos square theta over sin square theta is equal to 1 over sin square theta. How do you get it? See here, quotient and then reciprocal, quotient identity, reciprocal identity, and then we have our third Pythagorean identity. So we are able to prove all the three Pythagorean identities. Now we know that. Okay. Now what we try to do is how to use these Pythagorean identities in simplifying expressions and in simplifying equations. Let's see that. Let's take one expression. Let's take cos theta is 3 over 4 and then we wanted to find out secant theta. Here it's very simple that we know that secant is reciprocal of cos. So whatever the fraction cos is having, flip it, you get secant. Let's see how it is going. Look at here, cos is 3 over 4, then secant theta will be 4 over 3. Flip a fraction. Okay, and now we have, if cos theta is 3 over 5, and then we have to find cosecant. If cos is given and you are finding out cosecant, first find out sine. That's what we have done here, because we know that if we use our identity and if you can solve for sine, then flip the fraction for cosecant. Is it clear? I want that you should write down this one so that you can try it again. Okay? Please write down this and then try again. Now we will see how we can go ahead and simplify the trigonometric expressions. Okay? Let's do this. Okay, identities can be simplified, and simplify, what do we can simplify? Cos theta plus sin theta tan theta. We wanted to simplify this. Whenever sine and cos are there, just keep them like that. Do not do anything for that. But any other identity other than sine and cos comes, change them into sine and cos. Okay? When you do that, look at here. So I have used the quotient identity here, and then the next is cos theta plus sine square theta over cos theta. Then you get that this. Okay? And then this can be written as 1 over cos theta, and then that's equal to secant theta. Here. Okay? That's how we can simplify cos theta plus sin theta tan theta is nothing but our secant theta. This is how we can simplify our trigonometric expression. Let's see the next one. Cot square theta over 1 minus sin square theta. 1 minus sin square theta is cos square theta, and cot is cos over sine. So we have used the quotient and also we have used the Pythagorean identity, and then we can simplify this. A fraction divided by the fraction, the bottom fraction will flip and becomes multiplication, and then we can simplify this one as cosecant square theta. Okay? So all this is how we try to simplify the trigonometric expressions. Let's see the next one. Okay? Simplify each expression. Okay? So this is what? Cosecant theta over cot theta. Let's see this. Okay? Now, I want you to see wherever I want you to write down this, and then I want you to identify where we have used the quotient identity, where we have used the reciprocal identity, and where we have used Pythagorean identity. All these things we have to know, like where exactly we have used all the three identities in these three problems. So I want you to take down these problems, try it by yourself. Of course the answers are there, but still I want you to try. Now let's see for the equations. Now, here tan x times cos x is sin x. We wanted to prove Ls is equal to Rs. What's Ls? Left side. And Rs, the right side. So the right side of the expression should be equal to the left side of the expression. So that's what is this equation. So now we have used tan times cos is sin. So we have used that tan is nothing but sin over cos times cos x. We get the left hand side is sin x. Okay? So we have used that right hand side it is sin x, and left hand side also we proved it is to be sin x. Then left side is equal to the right side. So we have proved it. This is proving the trig equations. Now, proving tan square x is nothing but sin square x times cos to the power of minus 2x. Okay? Cos minus 2 we can write it as 1 over cos square, and sin square and 1 over cos square, that becomes as sin square over cos square, that's nothing but tan square. So we have proved that the left side is equal to right side. Here we have simplified the right side and we proved that left side is equal to right side. Now it is your turn. Now you have to prove this one, okay? And then this is also, please take this, tan x plus 1 over tan x is 1 over sin x cos x. Okay, I want that you should write down, try this, go ahead, please write down all these things and see if you have any questions in deriving this, please let me know, I will help you out more. Now go ahead, prove this one. Sin square x over 1 minus cos x is 1 plus cos x. Okay, here what is that we are doing is 1 over sin square x over 1 minus cos x. Then we are writing sin square as 1 minus cos square over 1 minus cos x. And we know very well that a squared minus b squared, we can give the multiplication, we can factorize it as a minus b and a plus b. See that? We can factorize it as a plus b and a minus b. That's exactly what we have done. And then after doing this, we can cancel out these two. And we get the left hand side is equal to right hand side. Okay, your turn. Write down this. Okay, and then prove it. I have given hint. Okay, thank you. And let me know.